Hey everyone, and welcome to The Explainer. I am so excited to jump into today's topic with you. We're going to take a look at the very foundation of how humanity actually explores the universe. We'll unpack what science really is, how it works behind the scenes, and, how it literally shapes the world we're living in right now.
But right off the bat, let's try a little thought experiment. Suppose you could send a robot to another planet. Just pause and imagine that for a second. What kind of experiments would you want it to run? Because before you write a single line of code, you've got to figure out exactly what kind of information you want that robot to look for, right?
And this isn't just a sci-fi movie plot. Look at the 1997 Sojourner rover. When it became the very first robot to explore Mars, scientists had to specifically program it to check out the Martian atmosphere, examine rocks, and measure gravity and magnetic fields. It really proves that science isn't just a dusty textbook you're forced to memorize, it's a completely active pursuit. It's all driven by that basic, profound human curiosity to ask questions and then build the actual tools we need to find the answers.
Okay, so here's our roadmap for The Explainer today. We'll start with curiosity and discovery, then move into science meets technology, mapping the unknown, rules of the game, and finally we'll wrap up with the unwritten future.
Let's jump right into Section 1. Curiosity and discovery, the starting point. You see, every single scientific endeavor out there, whether you're just checking out what's living at the bottom of a pond or launching a multi-billion-dollar rocket, starts with a simple spark of curiosity. So, the golden rule here is that science begins with curiosity and often ends with discovery. But here's the catch. Curiosity by itself isn't enough to get real results. You might be wondering what's inside a baseball or the exact perfect ratio of chocolate to milk, but to get a concrete answer, you need a method. You have to observe, and you have to measure. Sometimes those observations are just describing what you see, and sometimes they're hard numbers. But it's this systematic method that bridges the gap between just saying, I wonder, and actually discovering the truth.
Moving right along to Section 2, Science meets Technology, Knowing versus Doing.
So science and technology are definitely different things, but man, they are completely intertwined. The main goal of science is to expand our knowledge. It's all about knowing. Technology, on the flip side, is about applying that knowledge to solve practical, real-world problems. It's all about doing. And you really can't have one without the other. A step forward in one almost always triggers a massive leap in the other. Like when scientists figured out the physics of how certain materials conduct electricity, that directly sparked the invention of the transistor, which basically gave birth to all of modern computer science.
To really see this in action, just look at the evolution of the telephone. It was invented in 1876, right? Fast forward a bit to 1914, the tech is booming, and by 1927 you could literally make a phone call from New York all the way to London. Jump to 1955 and home phones are everywhere. And then hit 2003, and suddenly we've got mobile cellular phones loaded with apps and cameras right in our pockets. In just a handful of generations, applied science entirely revolutionized how humans communicate.
Just compare the bulky, cumbersome, old-school telephone on the left to that slick, portable 2003 cell phone on the right. Think about the sheer amount of physics, chemistry, and material science that had to be completely understood and then physically applied to make that massive leap happen. That right there is technology applying science to totally change our day-to-day lives.
All right, on to Section 3, Mapping the Unknown, the Branches of Science.
Because there's just so much knowledge out there, natural science is typically split up into 3 major branches just to help us organize the universe. We've got physical science, earth and space science, and life science. And honestly, these 3 pillars pretty much cover the whole shebang, everything from distant galaxies to the living cells inside your own heart.
Let's break that down a bit more. Physical science is all about non-living things, and its big hitters are chemistry, which is the study of matter and how it reacts, and physics, which covers matter, energy, forces, and motion. Then you have Earth and space science, which looks at our own planet and the wider universe, relying heavily on geology and astronomy. And finally, life science is strictly about living things, primarily through biology, figuring out how organisms grow, survive, and reproduce.
But I gotta let you in on a little secret. Nature doesn't actually care about our neat little textbook categories. The boundaries between these branches are always bleeding into each other. Just take biophysics, for instance. It is quite literally the application of physics to biology. When researchers study how a neural network in your brain fires, or how an entire ecosystem reacts to a shift in energy, they're using hard physical science rules to figure out life science. The borders are just beautifully blurry.
Which brings us to Section 4, Rules of the Game, Physical Science.
So, physical science lays down the ultimate ground rules for matter, energy, and motion across the entire universe. But to really grasp it, we first need to wrap our heads around the scale we're dealing with. 13.7 billion. That's the estimated age of our universe, in years. Just let that sink in. It is a completely mind-blowing stretch of time.
And if you think the age is wild, check out the size. The observable universe is roughly 700 billion meters across. That number is so astronomically big it almost loses its meaning, right? So to put into perspective, if you took the entire diameter of the universe and shrank it all the way down to the size of a giant beach ball, the Earth would be so unbelievably tiny, it would be completely invisible to the human eye. And a shockingly small amount of that massive space is even made of matter.
To navigate a universe this huge, scientists lean on what we call the four big ideas of physical science. We're talking about space and time, matter and change, forces and motion, and energy. You can basically think of these four concepts as the master operating system for the physical world. Pretty much anything that happens around you can be traced right back to these core principles.
Whether we're looking at a massive space shuttle that needs a ridiculous amount of force to break free from Earth's gravity, or just the regular stop-and-go forces of cars sitting in city traffic, both are governed by the exact same rules of forces in motion. Physics literally applies everywhere, no exceptions.
And, behind every single type of motion is energy. Now, energy comes in lots of flavors, but let's look at two huge ones. Kinetic energy is the energy of things that are actively moving. Potential energy is the stored energy of objects that have been moved against a force. But here is the absolute most important rule of the game. Energy is never, ever destroyed. It just transfers from one form or one object to another.
Think about a rowing team for a second. How exactly does that boat move forward? Well, it starts with the rowers eating food, right? Their bodies store that as chemical energy. Then, their cells use that stored chemical energy to power their muscles, which then transfers kinetic energy right down into the oars, pushing against the water to propel the whole boat forward. It's just this continuous, amazing chain of energy transfer.
And lastly, Section 5, the unwritten future, evolving perspectives.
It's super important to remember that our scientific knowledge is just the best, most up-to-date model we have for how the universe works. And models change. A perfect example: as our telescopes get sharper and sharper, we constantly find new moons orbiting planets like Jupiter and Saturn. So what we consider a rock-solid fact today, like the exact number of moons out there, is definitely going to shift as better technology lets us see further into the dark.
That's exactly why this quote is so crucial for anyone diving into science. Be skeptical, ask questions, be aware that the scientific facts of today might change tomorrow. Science demands that you stay actively engaged. You've got to stay wildly curious and keep a healthy dose of skepticism about the world around you. We trust the scientific process precisely because it's designed to fix its own mistakes and uncover new truths.
Which brings us to our final question for you today. If the scientific facts of today really might change tomorrow, what discoveries are you going to make? Because science isn't just a list of achievements by people in old history books. It's a living, breathing process, just waiting for someone curious to take the next step. You could literally be the person who rewrites the textbooks of tomorrow. Thanks so much for hanging out with me on this Explainer. Keep asking questions, stay curious, and I'll catch you in the next one.